Relation between F and R. This is concave mirror. P is pole, F is focus, C is center of curvature. In this case, this is convex mirror. P is pole, F is focus, C is center of curvature. Here, PC equal to radius of curvature, which is R. If we use sign convention, then it will be negative R. And PF is focal length, which is F. But in accordance with sign convention, this will be minus F. Here, PC equal to radius of curvature, which is R. According to sign convention, it will be positive. And PF, which is F, according to sign convention, it will also be positive. Now, consider one ray which is parallel to principal axis. This is principal axis, and this is a ray parallel to it. So after reflection from point B on the mirror, it passes through focus. So this is angle I, this is angle R according to the law of reflection, I equal to R. Since alpha equal to I, because these two rays are parallel, so I equal to alpha, alternate angle, hence alpha must be equal to R. So let's write these things. So angle I equal to angle R. This is law of reflection. Angle I equal to angle alpha, alternate angles. Which implies angle R equal to angle alpha. So side opposite to these angles must be equal. So we can say that side opposite to angle R, that is CF, must be equal to side opposite to angle alpha, that is BF. If aperture of the mirror is small, then B and P will be very close. In that case, for small aperture, B and P will be very close. So FB will be equal to FP. So from here, CF equal to FP. So F will be midpoint of CP, which implies F is midpoint of CP. So this CF and FP both will be equal. So CF equal to FP must be equal to small f, because PF equal to small f, focal length. So since CP equal to R and PF plus CF is also R, but PF is F and CF is also F equal to R. So from here, 2F equal to R or F equal to R by 2, which is required relation. Focal length is half of radius of curvature, or radius of curvature is double of focal length. Thank you for watching.